Section 7.2, statistic. Estimating a population mean. Now, this section, we can look at the formula, the summary formula, and the second case, which we want to calculate the mean. See, the first formula on section 7.1, we were trying to find range for proportions of populations. Now we need to find range for mean of populations. So, and then there are two formulas. Depend whether a standard deviation of population is given or not. So there are some terms or Greek letter that we use. This X with the bar is the sample mean. Means you have a bunch of samples and you find the average or the means. Mean of populations, we are using this symbol. Population mean. When you take some samples and you find the standard deviation of those samples, we are using the letter S. That is a standard deviation of samples. If you find a standard deviation for entire populations, we are using this Greek letter of sigma. That is standard deviation of the populations. So you should be familiar with these four letters that we use in the statistic. Again, the first two are for samples and the other ones for populations. For proportion, we don't really care that much about sample or standard deviation for sample or for samples or population. But in this case, they both have a different formula. Formulas are the same. It's just if you have a standard deviation of population is given in the problems, then you are using the Z table to find the Z. If a standard deviation of population is not given in the problem, which is most of the time that's the case because we always take samples. In that case, the only difference is we are using a different table. They call it T table. And I'll show you how we apply that in the problem. So there are two formulas. If a standard deviation of population is given or not given. Means in this one, how can you tell if the problem you see a letter S? That means you are using standard deviation of the samples. Or if you see the Greek letter of this, that means this is a standard deviation of population. It's just, they have to use a different table. See, use Z table for this and T table for that. We are familiar with Z table. We use that on previous sections. Okay, now we want to introduce that first. And these are the formula that we use in this section. Again, I summarize everything, but you should also hear. Mean of populations, this is the range for mean of population, which has the sample mean involved in it. And of course, all of them, there are some conditions. Requirement is sample must be a simple random sample and either or both condition always satisfy. N always has to be either greater than 30 or, this is the important one, N is greater than 30 or if N is not greater than 30, if the number of samples in the problem is not greater than 30, but if we indicate in the problem that population is normally distributed, then you're allowed to use it. So we allowed to use the formula as long as these two conditions are met. Normally the second one is important. So n has to be greater than 30, or we should state in the problem that population is normally distributed. This is a table. T distribution, table A3. Sometimes they call it a student distribution table. There is different. There is a column here, they call it degree of freedom. So what is degree of freedom? You know, let's say there are 10 numbers and mean of all the numbers is 80. That means that you need to sum all 10 numbers, which must be 800. And when you divide that by 10, you get 80, right? Now, let's say we give you 9 of those numbers, but number 10 is missing. How would you find that? So you assign any number to the first 9 numbers. You could put any number, but number 10 is important. Number 10 has to be calculated. So how would we calculate that? So let's say we give you 9 numbers, and when you add all those numbers, they turn out to be 750. Now you want to figure out number 10. Just let, you know, we give you 9 numbers, and this is 10 number, and you divide that by 10 is 80. Let's say you have that, right? If we give you the sum of the first 9 numbers, it could be any 9 numbers, as long as the sum is 750. You could put 9 numbers here as long as the sum of those 9 numbers is 750. Now, question is, we want to find the last one. So in that case, if you cross multiply, is 750 plus x is 800. So that number should be 50. So if there are 10 numbers, your degree of freedom is what? 10 minus 1, or 9 numbers. You have freedom of selecting the first 9 numbers, any numbers, as long as the sum is 750. Number 10 is the one that you need to figure out. So if there are 10 numbers and we give you the first 9 numbers, so you have the freedom of changing those to any number as long as the sum is that, degree of freedom is 10 minus 1, 9, but there is one that you need to figure out. So that's what the degree of freedom means in the table. And normally in the problem, we give you the n. When we give you an n value, then what you do is you just say df is n minus 1. Number you put in this column has to be n minus 1. Like if n is 15, then df is 14. Okay? All right, so then on this table, you see on the top, it said area in 2 tails, area in 1 tail. What is this area in 2 tail? Area in 2 tail. Let's say we have a problem that we indicate there is 95% confidence. The confidence level is 95%. So what is left? Area of 2 tails is 0.05, right? Area of these 2 tails, with the red is 0.05. If I take 0.05 and divide by 2, that gives me area of 1 tail. That's what you have here. Area of 2 tails is 0.05, and right above that is area of 1 tail, if you have that. So like in these problems, find the critical value, T of alpha half. You know how we had the Z on the section 7.5? They have T here when N is greater than 30. And if N is not greater than 30, we gotta somehow say the function is normally distributed. But here we just want to practice. So 95% confidence level and N is 15, okay? So when N is 15 and you have 95% confidence level, you come here. N is 15, so what is DF? DF is always N minus 1. So DF is 14. DF is 14 and confidence level is 95%, so you have that. So then on the table, these two are here. Area in 2 tail is 0.05, area 1 tail, degree of freedom is 15 minus 1, 14. That gives you the T of alpha half, is T, which is 2.145. So this number is, okay, that's where we get it. Now, if we call for Z, when we want to calculate, let's say if Z was, we want to calculate the Z, if the area was like, I don't know, 0.025, how would I find this Z value using the calculator? It would be second varus inverse norm, and then you put that number, 0.025. You'd say second varus inverse norm, area is 0.025. It was minus 1.96, right? Now, we also have it for T. Like in this example, is what, 0.025, right? This area is 0.025. So you go to second varus. Number 4 is inverse T. And then in the area, you put 0.025. DF was n minus 1, which is 14, and then you paste it to find the numbers. Second verse, inverse T, number 4. Area is 0.025. DF is what, 14? Minus 2.15. That's what you have here. Okay, so now we want to talk about the confidence interval now. Confidence interval for mean is, both are the same. Sample mean plus or minus E. Sample mean plus or minus E. How do I find the E? If in the problem you are using T, then you use this formula, and if you are using the Z, then you use this formula. Okay? T S over radical N. These problems, sample mean is given, S is given, and N is given. There are 15 numbers. They calculate for you the sample mean. Okay? So in that case, T of half, they already calculate. S is given in the problems, 2.9. N is given, radical 15. That gives you the E. Sample mean plus E and sample mean minus E. That gives you this. You could also use that, and you could use it. You could use your calculator for that, right? How does that work with the calculator? Stat, test. We are trying to find the interval, and is dealing with T. Number 8 is T interval. You see that number 8 T interval? And asking to find the sample mean. Sample mean is, in these problems, $30.9. A standard deviation is 2.9. See it better? And N is 15, and confidence level is 0.95. I already have all these numbers in. And the difference of this stat and data is means you already have, the computer already has the numbers already, right? So then you screw down to calculations. $32.506 and 20.93. Look at these numbers here. So you could always use your calculator and verify your calculations. Again, the T interval, which is number 8. All right. You know, the same idea we used for the section 7.1 use here. You know, when you want to calculate the mean, if you just add these two and the margin of error, so if we give you these numbers and we give you these numbers, if you take the average of those two, it gives you always the mean. And if you subtract this from the second one, divide by 2, it gives you the margin of error. So that kind of related to these problems here. Example 3. We also have n here too, right? And normally we use it when the standard deviation of population is given. Yes, standard deviation of population is given. That's how to calculate the n. Like in this example here, you put it a little bit higher so you can see it better. See? Assume that we want to estimate mean IQ score of population of statistical students. How many statistical students, n is unknown, must be randomly selected for IQ test. If you want 95% confidence, that 95% would give you this 1.96, the Z. We already calculated that, right? I mean, the Z for 95% confidence is 1.96. A standard deviation is 15. And margin of error is said sample mean is within 3 IQ points. 3, that would be the plus or minus 3. Is within 3 points. So that gives you the value of n. To these problems. A standard deviation known to be 2.9. See, when you see that sigma here, when you say the standard deviation of population is given, then you know you have to use the Z formula. See, if a standard deviation of population is given, then you are using this formula, Z. Because this one is given, okay? And I also show how to use the calculator for that. Look. You go to number 8, you put all this information, sigma, and then give you that. And this numbers was match that. As long as they're close, because you know, sometimes when it's more than 2, 3, 4 digits, we round it down or round it up. So as long as numbers are very close, we should be okay. these problems, use the summary statistic given in exercise 8, which is right here. I'll put it for you. I pasted it here so that would, remember this problem we did? They are saying now for that problem, let's just use a different number. Let's use N205. See, this one, N was 15. They are changing some values. They are saying, let's change N to 205, sample mean to 30.4, and S 7.1. So you are using all these values for the new problems. And I'll show you all the calculation here. It's very similar. See? N is 205, this is that. We calculate the E. Sample mean plus E, sample mean minus E. That'll give you. Now, if I want to use the calculator, I'll also show the calculator here too. Okay. Go to stat, test number 8, input these informations. The calculator will give you numbers very close to that. See, they're very close. Here, 3146, this is 3138, 2942, 2934. Obviously, calculator is more exact than hand calculations. Now, like in these problems, you know, sometimes we don't give you the sample mean. You have to calculate that. How would I calculate sample mean when you have some numbers? You know, we had the formula that if you have some X and you want to find the mean, this was the formula, right? Sum of X2, sum of, you know, to find the sample, and this is how to find the mean. This is, mean is sum of X divided by N, and the standard deviation is that. So we did that in chapter 2, but now it's easier to use a calculator since you are familiar with the calculator, okay? So what I need to do is input all these numbers into my calculator. I want to put all the numbers in L1. I already have L1 and L2. There are some numbers from the previous problems. I want to delete that. If you want to delete it, go to stat. Say clear the list. You know, you don't have to put in L1 or L2. You could use L3 or L4. But if you want to put everything in L1 or L2 or want to clean it, just go to number 4 and ask you, what list do you want to clear? L1 and L2. You go to second, and then L1, where is L1? L1 is under 1 here. See that L1 here? And then I want everything clear on L2, although I don't need L2, but the comma is right here next to X2, comma, L2, right? So you go to second, and number 2. So that's what you have. Clear list L1, L2. Done. Now let's see. You go to stat. I don't have anything in L1. Okay, so I'll go ahead and put the numbers. 2, another 2, 1, 4, 3, 3, 3, 3, 4, 1. Okay, 11, waiting for 11 means already input 10 numbers. Let's double check. Do we have 10 numbers here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes. Okay, so you have 10 numbers here. Now, you want to calculate the mean and the standard deviations. Go to stat. Remember calculations. The very first one, one variance stat, enter. All my numbers in L1, not L2. So I'll put second L1. Okay, that's all I need to put my L1 there, calculate. It gives you the mean. Mean is 2.6 and S of X is 1. We normally use this one, 1.07. 2.6, 1.07. See? So now I want to find, it said 95% confidence interval, right? So we're looking for T. Why we are using the T, not Z? Because we are taking samples. When we give you some numbers in the problems, you're sampling. Either that, or you don't see the sigma here, do you? Do you see this one, sigma? No. So that means it's a samples, okay? When it's samples, that means you gotta go and use the T table. Either that, or go to inverse T and put 0.025. It was 95%, right? So each tail is 0.025. So inverse T 0.025 comma DF. Some of the calculator, it asks you for area and the DF in this format. So you put those, that would give you the T value, or you could use the table. So you have the T of half. This is the formula. Margin of error is T times S divided by radical N. You have the sample mean plus or minus E. So that's how to calculate range for the mean of samples or populations, mean of populations, when you have a sample mean and you have the margin of error. All right, that's end of section 7.2.